Okay. So as you can see, so before we do this exercise, I want to know her in series connection. In a parallel connection, what do you know about a parallel connection? Reborn hore. Hmm? What do you know about a parallel connection? Hmm? What do you know about the series circuit, guys? In series circuit, what's going on with the current? What's going on with the voltage?
The current is the same, sir.
In a series circuit.
Yes.
So in a series circuit, the current is the same. Menger. You are right.
Yes.
Well done.
Because ke na le badi ke itse nna se.
Another body.
Ke na le
So the
badi.
so okay, let's talk about the parallel connection here. On a parallel connection, what's going on with the current?
The current is divided.
Yes.
The current is divided. And what about the voltage?
It stays the same.
It stays the same.
Okay. So if the voltage across 8 ohm resistor is 4, what's gonna be the voltage across the 4 ohm resistor?
So where do we take that for?
Nah, I'm asking, Hori. If the voltage across the 8 ohm resistor is 4 volts, what's gonna be the voltage across the 4 ohm resistor?
4 volts.
Why?
I can say they're in parallel, so the potential difference is going to be the same.
Yes, it's gonna be 4 volts. On line. And if the current here is 0.1, and what's gonna be the current that is gonna be here? Hmm?
So is it going to be 0.1 plus that current plus 0.3?
Why do you say that?
I can say in a parallel, the current is divided, so it's not the same throughout.
Yeah, the current is divided. Yes, that's correct. So now, sharp, ne? These values I just designed them, like these are not the actual values, Anger. So sharp, what do we had there? If you check the details here, ne? If you check the details, we have the current that is passing through 8 ohm resistor, and we have the 8 ohm resistor there. What can we get from that too?
You get
So
the voltage. So
We can get the voltage. Okay.
Yeah.
So can we please, Sharp, now they want us to determine the reading on the ammeter one again. And they tell us about the reading across V2. Sharp, can you please calculate the reading across the 8 ohm resistor? What's gonna be the reading of the voltage, guys?
To come up voltage for the 8 ohm resistor again.
Hmm.
2,4 volts.
It's gonna be 2,4 volts.
Is
So we're going to have 8.2.1 R V over I, right? And we're going to say 8, the V is what we are looking for, over the I. The I is going to be how much? I is going to be 0, 0.3. And what's going to be the voltage?
2,4.
Going to be 2,4 volts, right? So
Yes, sir.
basically, the voltage here is going to be 2. And what's going to be the voltage across the 4 ohm resistor? Mhm. What's going to be the voltage across the 4 ohm resistor?
2,4.
Yes, it's going to be 2,4. which is 2,4. So it means that we can calculate the current that passes through the 4 ohm, right? So please get the current that passes through 2,4.
So I got 0.6.
0,6.
Yes,
Okay. Then calculate the ammeter reading on A1.
0.9.
Yes, it's gonna be 0,9. You get that? Basically, you know that the ammeter across form resistor is gonna be 2,4. You repeat the same thing. Going to see 4 and 2,4, I mean. 2,4 over I. Then your I is gonna be how much?
2.4
0,6.
divided by 4. Yes, sir.
No, I.
0.6.
It's gonna be 0,6 amps. So, and now the I think it's I1. It's gonna be equals to how much? 0,3 plus 0,6, which is 0,9 amps. That's the ammeter reading on A1. 0,9. Right? Now they want you to calculate the resistance across Z. What's the resistance on Z? What's the resistance on Z?
Yeah. Say,
Yes.
please explain how we substituted to
Mm-hmm.
get. Gary, please explain how we substituted to get 0.6.
Askere, remember the voltage is the same, right? The voltage is the same on the parallel circuit. Then you're going to say R equals to V over I, right? Already you have the voltage, already you have the resistance. So we're going to have 2,4 over I, right? Then you solve for I. When you solve for I, you're going to have what? 2,4 divided by 4, which is 0,6 in decimal.
Okay.
Yeah. So guys, who got the resistor Z? Hmm? Who
I
got
got I got
hmm?
17.2 ohms.
What did you do? Explain to us, what did you do?
Okay, so I used the formula R is equals to V over I, and then for V, ke substitutile the 15.6, and then for I, ke substitutile the 0.9, and then I got 70. It's supposed to be 17.3 ohms.
Yes.
Hmm. Oh, no. Ay, mara wena boikanyo. O rata go nkera motho o mobe.
Same. Ya gago e ntshwarisa PTSD.
Aowa, no. Ne ke sa e bone le nna ke gona ke e bonang mo ntlhaloganya.
Okay, so
Because she's right. Because the current that passes through Z ke bokae? Ke 0,9 ankere. And you already have the current, which is 15,6. But remember, if you check A1, the current that passes through here and the current that passes through here, it's going to be the same, which is 0,9 amps. So this 0,9 amps is going to pass through 15,6. Therefore, what's going to happen? You're going to say R V over I, right? And this is going to be the Z, and V is how much? It's going to be 15,6 over 0,9. And what's going to be the answer?
17.33.
Well, it's going to be
Yes.
17,33 ohms. Well, so it's going to be 17,33 ohms. So now calculate the total resistance of the circuit. Now we are going to 8,23. Calculate the total resistance of the circuit. Yeah. Well, so yeah.
Se re bona eng?
Here are the total resistance. The total resistance.
Ich say I got 104/45.
104.
Yes.
In decimal, how much is it?
Mm, 2,31.
Mm-mm. 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 Mm-mm.
So the external resistance, Anger.
So
It's how much?
So I got 19.99.
Yeah, wa bona eo ke dumellana le yona eo.
so can you please do it so I can see how it's done?
Bon, lo thoma go calculate the parallel side anger.
Okay, so
And what's gonna be the parallel side? It's
it's
gonna be
gonna be
1.
8/3.
Yeah. 1 over 8 plus 1 over 4. How much is it?
It's 8/3, so
Which is how much?
2,67.
2,67 anger. Then glory
Mm.
R external is gonna be equals to R parallel plus RZ.
Oh, okay.
2,67 plus 17,32.
Okay. Got it.
Mm-hmm.
Okay. Thank you, sir.
I heard there was someone who was agreeing with you. Who was that? That's just that I didn't see who was speaking. Nelma.
No one was agreeing, sir.
Hmm.
Was anyone agreeing?
No.
No, sir. Because Grabo was saying she got 19,99. So no one was agreeing, sir.
Okay. So it's gonna be 19,99 again.
Yes, sir.
So now calculate the internal resistance of the circuit. This one I'm not doing it. You have to get it right. How much is it going to be? Let me give you 5 minutes. Lafetha.
Yes,
Yes.
sa ke bolelang tshware ke e kry-ileng.
Income.
Ke kry-ile 1,12. Oops.
I got 1,11.
1,11.
Yes, sir.
1,11, so that's what I got.
Mm. But I have a feeling it's right. I don't know why. You started by calculating EMF, ne?
It's there, so I get it's 19.
I mean potential difference.
No,
No,
say.
sir.
Can't really, man. Arbon.
Is equals to the total current times R external plus R.
Mm. I toot oh I R plus R, ne?
Yes,
And already we have 19 and 0,9 R total, which is 19,99 plus R. Then you solved for R, ne? Hmm? From this point.
yes,
Then this divide by 19. What is it?
it's
to 1,11, sir.
21 comma 21,11 is equals to 19,99 plus R. And I'm going to take this to the other side, which is 21,11 minus 19,99, which is R. What's going to happen?
1,12.
It's going to be 1,12, which is equals to R. Yeah. So, by the reading Z, it is replaced by the new resistor, whose resistance it is smaller than Z. Well, the reading on voltmeter 1 connected across the terminal of the battery increase, decrease, or remain the same? Hey, what's going to happen?
It will decrease.
Decrease. Why decrease? Why decrease? No, Scatso, why decrease? You might be right though.
Ish, say, it's animal.
You might be right.
Okay, irkizami. Ankere he resistance that it decrease, honey. Like it is small.
Mm-hmm. Mm-hmm.
Le external resistance you decrease that one.
Yeah, the external resistance decrease. Yeah, I agree. I agree. Then,
Yes. And then that will cause the total current to increase. And then
no, don't touch the partial current. Don't touch the partial current. Bella, you should understand the relationship between the resistance and the voltage. Because if you check this out, ne, you mentioned an important point. This is 8.3, you said decrease, ne? And you mentioned an important point, and you said when resistance Z, when Z goes down, it means that it will cause the total current to go down. And remember, R is equals to V over I. And what is the relationship between the voltage and the resistance? When the resistance goes down, the voltage will go down. Because of they are directly proportional. I get the tlhalohanya.
se ka o tlhalohanya.
Then hence the V1 is gonna go down because of the resistance. Because Z, when you're going to explain, you're going to say when when resistor Z goes down, 8.3.1, when resistor Z goes down, not goes down, basically decrease. Ne? Decreases the total resistance of the circuit decreases. Anchor. And hence resistance of the circuit is directly proportional to the voltage. Ne? Hence, the total voltage, which is the potential difference, will decrease. Fernito. Lanswara, Anchor. Do you all get it?
Yes.
Okay. Now let's do this question. Gosh, this question, it was already done, but let's do it. Eh, eh. Can you please do this question? Go dim. Ke batla yona. So I need you to do 4.1 to 4.4. I'm giving you 10 minutes to finish everything. And if you don't understand, you can ask questions. Mm. For now, I'm coming back, but I'm not going to take long. Just going to 2 minutes 30. Ish. Hey, are you guys winning? Samaya.
Place it on record that it is the Christmas.
Hello, are you guys still there?
Yes,
Say I'm not winning.
You're not winning. Eva,
Yes.
what's going on? What's going on? Okay. Ohm's law, here is it. It comes again, guys. You have to know how to define Ohm's law, right? So now they want us to. Yes, yes. They want us to calculate the circuit, the ammeter A1, ne? But I want to do some simulation because of I know it's gonna be difficult for me to 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 understand this. It's gonna be difficult for me to explain this. Ne? But let me try and draw a circuit. So whatever. Then we have a closed switch. Gonna be A1. I think the circuit is like this. Okay. Ne? Then we have 8 ohm. We have 16 and R. Right? We have R1 and R2. A1 and A2. And Internal resistance is 1 ohm. And oh, yes, I'm coming back, ne? Shaka. Ngiyaphila kunjani? Hello. Ngizwa. Hello. Ah, sorry about that. So this is V. Eish. Yeah, eish. So across, guys, I need you to understand the connection, eh? The connection. And I even forgot the resistor here. There's a resistor here, which is A1, and there's a resistor here, and there's 20 ohm, ne? So if, let's say, for instance, the voltage is 12, ne? What's gonna be the voltage across R here? Hmm? Guys, are you still there?
Yes.
What's gonna be the voltage across R?
I say 12.
Are you sure?
No, I'm not sure.
Anyone else? What do you guys say? Do you still say it's 12?
And now I say it's 4.
It's 4.
Wait, where do we take the 4 from?
Come on, with it for going to
Ay, so tama ish. Now ring. Ring.
Girle, like when you have the voltage across the 12 ohm resistor, the battery, I mean. Now I want the reading on the volt, like on the R.
Which are
She resistor R. No. It's going to be how much? Okay, I need you to understand something, ne? Erkires. So little kgona go e understand that pele. Because of this is what I did with the grade 11s. Yabo. Eish. Electric. Yes. Kopaleng thuseng go e aga this thing. Okay. Hey, man, I'm losing something.
It's an emitter.
Emma. No, not exactly an ammeter. Construction yaga it's a bit wrong. Yeah. No, don't join let that guy there. Uyabona? Tonsile ijoyiniswe. Yes. Then yeah, tonsile ibisi. No, diameter le di-resistor di tlo ba sharp. Then e re ke ise ku 12. So in this, okay. Yeah, let's say it's 11 volts, ne? Then I see my voltage here. So this, it's R, anchor. This is the R. So now I want to focus on this R here. I want to focus on this R. Do you get that?
Yes.
So sharp. Since I want to focus on that R, and you see, I want to assume where my battery it's 11 volts. It's 11 volts. So I asked Hori, what's gonna be the voltage across the resistor R? You guys said what? 12 volts or 11 volts, I get. So check. If I measure, this is gonna be 11 volts, I get. So this morning for 2.75 volts. Why? Hmm? Oh shit.
Is it the emitters?
No, diameter na bothata. Diameter na bothata. Ngikutlwisisa.
Yes.
I think the connection nje ke yona flow.
Mm. Let me see.
No, connection because
Because that part is supposed to be connected to that 20 ohm resistor.
ikantura mo. Eish. Ntho ena lo frustrate nyana, wait. This this voltage must come here. Ongulusis. Then it cross like this. Then more it cuts. Then it joins like this. Yeah. Ash.
Yes.
Pila secretary na is. Lebo.
Yes.
Yeah. Now this is gonna be 11 volts. Lebo. Do you see that? So it means we're
Yes.
across the this is gonna be 11 volts. Where one. But now here's my question. What's gonna be the voltage across V3? Or let me just start V there. What's gonna be the reading across that V? Hmm? What's gonna be the voltage across that V? Who can try? It won't be 11 volts though. But what's gonna be the voltage?
Se ka o no bona go itlo re ya lo itse. O ka go
As 11,
mpone.
as 11 volts. So, but what's gonna be the voltage across these two? That is gonna be 11 volts. Because
When it's
of
like
this
this.
section, because this section is parallel to R. On good is,
Okay.
but this series circuit and this guy, they are sharing this 11 volts that is up there. A ke itse gore la ntlhaloganya na? Because of
Yes.
this and that guy, they're in series. So in a series circuit, we have potential dividers. And if we check on a simulation, if we check on a simulation, if I measure from here to here, do you see what it's 11 volts?
Yes.
This is like this basically. By one. But the voltage across these two is not 11 volts. Because of why this resistor here, let me go back. This resistor here and this parallel resistance, they are sharing this 11 volts that is across them. On good basis, since they are in series with each other. And on the simulation, we got this to be 3,67. And what's going to be the voltage across this guy over here? It's going to be 11 minus 3,67.
7,33.
What's going to be how much? This is going to be how much?
7,33.
Going to be 7,33. Anger.
Yes.
So check this out here. Get 3,67. Then I measure across this guy. Bon. Do you see that? Because of the two,
Yes.
they're in parallel, they're in series with each other. Do you get it? But the whole of the top part, it measures 11 volts. Because of why? Do you see this whole setup at the top there? This whole setup here, it's in parallel to that R. How do you see parallel branches, guys? Obviously, the only time whenever you want to see a parallel branch, obviously, you have to notice the points here, the split points. And get the moment there's a split point, you have to think about the parallel resistance because of why the total current comes from the battery. And get where one. But the moment this goes up and the other one goes down, already in your head you have to register this thing. No man, there's a parallel circuit here. One tlhalohanya. It means already this whole section is parallel to R. Mara guys, do you understand what I'm trying to say here?
Yes, sir.
So that's how you identify your parallel resistance. So now you have to know that the total voltage R and that top part, they are parallel to each other. So let's see what on the question they're looking for. Now they're looking for the ammeter on one. So barring the switch, when switch S is closed, the current that passes through 8 ohm resistor is 0.5. So the current that passes through here, it's 0.5. The current that passes through there is gonna be 0.5. Where the current that passes through there is gonna be 0.5. 0.5. Then waringi, calculate the what do you call this? The current in A1. They want the current that passes through A1. On good says. So how is the setup? How is the connection between the 8 ohm and the 16 ohm resistor? Huh?
In
How is the
parallel.
it's gonna be in parallel and get, but
Yes.
what can we get from this information? We have the ammeter, we have the what do you call this? We have the current and we have the resistance. What can we get?
We can get the voltage.
We can get the voltage and get.
Yes.
So what's gonna be the voltage?
I'm working on it right. Okay. It's gonna be in times
Can I be
4.
possible?
It's gonna be 4, right?
Yes, sir.
Yes.
So it means that I'm going to say 4.2 R V over I, and I'm going to say 8 divided by V over 0.5, and my V is gonna be 4 volts, right? And check, this is going to be 4 volts, and what's gonna be the voltage across the 16 ohm?
4 volts.
It's gonna be 4 volts, and get
Yes, sir.
it's gonna be 4 volts. So I need the current that passes through 16 ohms now. What is it going to be? What's gonna be the current that passes through 4 volts?
0.25. Let's see. 16 is equal to 4. Yeah, 0.25.
So R is equals to V over I, and we're going to have 16 is equals to 4 over, yeah, over, I could say, oh yeah, go on.
See.
No, go on.
Yeah.
No. I thought it's something else, but I realized, or no, I want 0.25 and get. So this is gonna be the current that passes through here, amperes. Then what is gonna be the current that passes through A1?
Is it gonna be the sum of 0.5 and 0.25?
Mm-hmm.
Okay.
So I1 is gonna be what?
It's gonna be 0.75.
It's gonna be 0.5 plus 0.25, which is 0.75 amps. And what is gonna be 4.3? So on 4.3, they're saying if the device R delivers, see, the power of 12 watts, calculate the reading of ammeter 2. Wait, one. So now, these are the formulas of the power. P, P. These are the formulas of the power. Then more on the R, this it delivers how much? It delivers 12 watts, ne? Then what calculate the what do you call this? The current through A2. So now we have 0.75, anchor 75. And what do we have? And I want to ask a very critical question. Ne? And I want to ask the very critical question. Ne? I want to know about a current here. Or what's gonna be the voltage?
Is it 4?
The voltage is gonna be 4, ne?
Yes, sir.
Okay. So can we get the voltage across this guy here? Hmm? Can we get the voltage across that guy? Guys, what is the V there?
So I'm gonna type it.
Hmm?
I'm gonna type it in the chat box. Give you a shy.
Sir,
Yes.
why do we have to calculate for the voltage there?
Why?
Yes.
Because of I need the voltage here.
Really?
Mm. Check. What is 3,67? What is 3,67? Ne? It's just that it's gonna be a mess. What is 3,67 plus 7,33?
It's 11.
Hmm?
6, it's 11.
It's
Yes,
11.
11.
Ewan, kan die voltage die vir die 11? Eh, eh. So it's gonna be 11. So check this. Do you see it? Now do you see why Butle, why I need the voltage here?
Yes, sir.
Mm.
Se,
Mm-hmm.
before ke pretend ka re ka tlhaloganya ne se.
Mm-hmm.
Akere keng 8 ohms plus 16 ohms plus 10 ohms e parallel to R.
Ke
And
mametse
then
phe.
that
Eh?
V there,
Ore, yeah.
ema pele. So the V ya 20 ohms, it's gonna be
Why you break
eh,
it?
ya R minus 4V.
Hmm? Orenge? Ish, wa break. I don't understand why you break it.
Can you hear me now, sir?
Awangutlo.
Yes, sir. Buhle, can you hear me?
I can hear you. I think say network
I think
ekero.
it says the one that's breaking.
Yes.
Yeah. Hey, erge chifte. Yeah, well, I like good.
Can you hear me now, sir?
Yeah, I can hear you now.
No. Okay. I get it. 8 ohms, 16 ohms, and 20 ohms, they're in parallel to R. I get it.
Uh-huh.
So if I understood this correctly, from the that project thing you just did now, to get the voltage at 20 ohms, we would have to subtract the voltage at 8 ohms and 16 ohms from
No,
voltage
you
at 3.
misunderstood me. You have current, you have resistance. You can get
Okay,
the
calculate it.
voltage.
It's 15.
Voltage is 15.
Yes, I also got 15.
It's 15. So I can 0.75 times
Mm.
20.
I
I
don't know.
also got 15.
Yeah.
Okay, I don't want. Maybe it's me. Then we have the resistor, which is how much?
It's 20 ohms.
Gonna be 20 is equals to V over 0.75. And what's gonna be the V?
It's 15.
Okay. So it's gonna be 15. So what's gonna be the voltage here?
90.
Yes. So total V is equals to 4 plus 15, which is 90. So it means over here I'm having 19 volts. Then you have V, and you have power. Can you get since you have voltage and you have power, can you calculate the current? Which formula are we going to use?
Gonna have voltage. The first one
The first one again.
is
So what are we going to have? We have the voltage and we have power. So we're going to have V. P is going to be V over I. And we're going to say 12. It's going to be 19 multiplied by I. And what's going to be your I?
0.63.
Gonna be 0.63 amps. Right one. Gonna be 0.63 amps. Then they're saying calculate the reading on the voltmeter when the switch is open. What are they looking for? Hmm? What are they looking for? When they say calculate the reading on the voltmeter when the switch is open, what are they looking for exactly? They are looking for EMF. Or a Alan Swar.
Le bone se drama kana.
I said drama.
Ba ne ba sa bue ba ra batla EMF ba fetsa story ra kwala.
They want to see how you understand what you're doing.
How se. Ano ba ya kwali kwa.
But like, if you did this type of experiment, you will realize that if you switch on, like if you build a circuit, ne? Let's say you low makuleng, regular battery ya 12 volts, for instance. Konhlalo. Let's say this is your one, and this is your bulb, and this is your ammeter. This is a short, a just smaller yana circuit, and a switch there. One, and this is a switch. But when I hear so your battery is gonna be 12 volts. So I'm going to say. But when the switch is closed, this value it decreases. Maybe it becomes 11.5. I'm going to say this is no longer like this is no longer an EMF. This is a potential difference. One understand?
Is
This is no longer a voltage. This is a potential difference. So now they want you to calculate for the potential difference. One. They want you to calculate for EMF. So sharp. How do you calculate for EMF? 4.3 or 4.4? Well, remember, we have the internal resistance, which is 1. And how do you calculate for the internal resistance? Well, it means you have to look for and I already ne, if you check something ne, already you have the current that passes through here. Tell me if I'm lying ne? You have the current that passes through here, and you have the current that passes through here, and the current that passes through here. It means where you can get the current that passes through here. Or am I lying? Because of here you have 0.75, and here you have 0.63, I think. Right? And you can calculate the current that passes through there. That comes, no, it is facing in the wrong direction. It's supposed to face in that way. Oh, so what's going to be the current that passes through here? Hmm? Hmm?
0.3.
Ah,
Yo,
ah.
like sa itse se.
Ah. So the current that passes through there, the current that is because of this current and that current, they're going to meet at this point here, and they're going to join together and move in that direction. So you're telling me or that current is gonna be 0.38.
I said 1, say.
What?
1,3. Check is the sum of 0,75 and 0,63.
Oh,
Mara
I
say 1
thought
plus honestly.
I thought no, I thought it says 0.38. So it's gonna be 1.38, Anger.
Yes.
Yes, that's the correct one. So you're going to say I total is equals to I1 plus I2, which is equals to what? 0.75 plus 0.63, right? 0.75 plus 0.63 is gonna be I total is gonna be 1.38. Then now I need the total resistance, total external resistance. It's gonna be how much? It's gonna be how much? Can you please calculate the total external resistance now? Oh, there's no need because of Mara, it's fine. Because of if you have the current and you have the voltage here. Kara, what's the voltage here? What's the voltage across R?
So can we please go back to our workings?
I think 19.
90.
Oh, it's gonna be
Yes,
19.
19.
Yeah, please calculate for me that R there. It's gonna be 19 over 0, comma
6,
6 in
3.
yeah 6. It's gonna be how much? What's gonna be the resistance?
30,16 ohms.
Mm-hmm. So since here you have 30,6, please calculate the total resistance of the circuit. The total external resistance of the circuit.
Um,
Oh, I can, Mara, there's an easy way, guys. There's an easy way of doing this. There's no need for us to use this resistance. That's a long way. It's fine. Ne? There's an easy way. I've been trying to, because I can see it's 3 marks there. But how we do it, it's unnecessary. Yabona? It's unnecessary. So let's avoid an unnecessary thing. So we have 1,38, right? And please calculate the V lost. Because of you have 1,38 here, and you have the current that passes through 1 ohm resistor. So please calculate for me the, what do you call this? Please calculate for me the current through the voltage lost. Please calculate for me the V lost here. Here. Hmm? What's gonna be the V lost? Remember, the V lost is going to be what? R V lost over I. Then it's gonna be 1, and the V lost is gonna be V lost and 1,38. Then what's gonna be the V lost? It's gonna be 1,38 and
Yes.
Mm. Then the EMF is gonna be how much? It's gonna be V potential plus V lost. Wait, one. Then what's gonna be the potential difference on this V? What's gonna be the potential difference here? If you check this, wait, one. It didn't change. Do you see that? So what's gonna be the potential difference? It's gonna be 19 and
Yeah.
it's going to be 19. Then EMF is going to be 19 plus 1,38. Then the EMF is gonna be how much? 20,38
Yes.
volts. 20,38 volts. Then kuningi la. So let me do this. Mm-mm. Mm. So yeah, already the workings are available. You can study them, and please continue to do number 5.1. Then tomorrow we are going to do it, ne? We're going to do
Yes.
5.1.1 and whatsoever. Then yeah, I think that's it for today. Let's continue later on.
So we're still busy with chemistry later on, me.
Yeah, they're still busy. No matter if you're busy with physics, it's fine. Like you can study physics or
Okay, so and I'm still doing chemical equilibrium then, eh?
yeah, Casey.
Okay.
Mm.
Okay. Thank you, sir.
No problem. No problem.
Thank you, sir.
Sharp, sharp. No problem. Thank you, sir. For sure. I know flop.